your ear.
All
right.
And then lay eggs. And then you put in the Spider-Man.
Oh.
Yeah. That's how that works.
That's how it works. Dude, I had a spider bite in my ear and I thought it would be Spider-Man, dog.
No.
I was determined to freaking shoot webs.
All right. Everyone's good today? I hope.
Heck yeah.
Yeah, pretty phantasmal.
It is a Monday. Guess we have. You guys have like a 4-day weekend next weekend, huh?
It's like a 5-day weekend.
Yeah, I mean, because there's that. Yeah.
Why?
I don't know. I'm not there to make those rules. They don't consult me for that information. Okay.
Mr. Strip, can you explain the video on your YouTube page that says Michelle's homework?
Oh, another teacher had wanted to post it. Because I have a YouTube page, it defaults right away to it. So.
You just legit just gave the kids the answers. That's basically what you did.
Yep. All right. So we are going to continue with our adventure of factoring. The only thing that's different is we're going to put an equal sign. So if I put an equal sign, I'm actually trying to figure out what x is equal to, which is just one step further. All right. So if I had x times y equal to 0, I would know that if I were to have x equals 0, then that would be a true statement. Or if y were to equal 0, that would also be a true statement. Agree?
Yeah.
Because x times 0 would be 0, or y times 0 would also be 0. Okay? And so that would say, hey, if I plugged 0 comma 0 in, because that's an x and a y as a point, that would be true as well. Ooh, I don't know what this is. Is this a menu that can... What is this? Oh, look at this. Zero product property. Zero product property just means, hey, what can I plug into the equation? The whole thing becomes 0. That's a zero product property. Good so far? Anyone lost? Good. Yay. Let's move on. Ready? Okay, so this next one, so I'm not too concerned about the 5, but I'm going to look at this part right here. What number or numbers could I plug in for x that would make that 0?
0.
0 minus 3 is negative 3, but good try.
3.
3. All right, so if I put a 3 in here, if I made x equal to 3, if I were to do the actual math, which means 0 equals 0. So 3 is a solution to this problem. Okay? So is there any other number I could plug in for that on number 1? And get 0? No. All right, so let's take a look at number 2. So I have this one here, but I also have this one here. So for the yellow, what number do I plug in to make that yellow part 0? Negative 5, right? So if x is equal to negative 5, I get negative 5 times 0 is 0. What about for this letter here? Ethan, you know this one. Here's your first answer.
That's 5.
No.
Negative 5.
No, here's your first answer.
0.
0, there you go. So this one, I have two solutions. There's two different ways to make the whole thing equal to 0. About problem number 3.
Just gotta think.
I got highlighter. I got here. I got here. And I have here. It's not my phone. Mine's charging in my office.
Flip phone.
All right. So, what is one solution on that number 3?
I think it's -4.
Okay, a -4?
Positive.
Positive 4, because 4 minus 4 makes it 0. What's another one? It's another solution.
1.
Close?
-1.
-1. Anything else?
0.
Yeah. So now I have 3 solutions. So there are 3 ways to solve that problem. There are 3 solutions. And what a solution also means is it will cross at some point, it'll cross the x-axis. Okay, but we'll get to that later. Number 4, solution or solutions.
2.
Just 2. That's the only solution. Agree? Let's move down. Ooh. Ooh, you know, it was like kind of all fun and games now, but now we're getting kind of serious, and I can't just look at it and get the answer, can I?
No, sir. Does this mean we have to use decimals?
No! So all you're going to do is you're going to take each of these and set that equal to 0, and then you're going to do this as well, and you're going to set that equal to 0. Oops. All right, so first semester we learned how to get this equal. So I add 3 to both sides, right? So I get 4x, those cancel, equals 3. How do I get x by itself here? Divide by 4, good. So this has an answer of 3/4. So I guess you could say you can get decimal answers or fraction answers. What about that second problem, 2x plus 9? How do I solve that for
It's
x?
4.5.
4.5, because if you subtract 9 from both sides, those cancel. So I get 2x is equal to -9. Divide by 2, divide by 2. So I can get -9 over 2 or -4.5. I totally accept it. So that has 2 solutions. Hey, was number 5 or any of these, we could FOIL them back together and get the original, right? But they didn't want us to do that. They just wanted to solve these. We doing okay on notes?
Oh, do we eventually have to find the solution?
Yeah. So it's one step beyond factoring.
Okay.
Cool? We good? Can I move on?
Yeah.
Good?
Yeah.
Perfect. All right. So recall that the value of the function is its y value, the x-intercepts of the function. So the x-intercept, let's see where this is going. Oh, okay. So the x-intercept is like right here. So this would be called the solution. We're worried about where it crosses the x-axis. So that'd be 1, 2, 3. Looks like the point 6, 0. So if x were to equal to 6, that would allow me to have my solution. So your solution is where you cross the x-axis. Where it crosses the y-axis is another point, but it's not the solution. Okay? Ready, Freddy? What happened? Okay. So the fundamental theorem of algebra. You had no idea you're going to walk in on a Monday and get the fundamental theorem of algebra. Whatever exponent, so whatever number is the highest exponent in your problem is how many possible solutions you have. Okay, so if I had x raised to the 300th power, I could have 300 different solutions, meaning 300 places it crosses the x-axis. Okay? Now, I want to doubt we will see that type of problem in here. But just whatever your highest degree is, so your highest exponent, no matter where it is in the problem, can point to how many solutions exist. And a solution is what you plug back in to make the whole thing 0. But it also could be where it crosses the x-axis, as long as we're talking about the real number system and not the imaginary number system. And I kid you not, they are called that. All the numbers you have dealt with in here are called real numbers. The imaginary numbers is when you have a square root sign, still with me on the square root sign, and put a negative underneath. Those make them imaginary, which fall into the complex numbers. It's goofy. I don't know why they did that. I had a student whose dad argued with me. And it was funny because there's number systems. The main one we use is called the real number system. And then because you have a square root of negative numbers, that's called the imaginary numbers. So this dad says to me, why are you having the kids look at imaginary numbers? This is like make-believe. So no, they're called imaginary numbers. He goes, well, why aren't they using the real numbers? It's like, well, for the most part, they are using the real numbers. But there are sometimes they're imaginary numbers. He goes, why would there be imaginary numbers? And the thing is, it's a number system. That's what the name of it is. It's like saying, oh, there's a Tesla over there. You know, that Tesla versus a Chevy. There are two different types of cars. So you have a real number system and you have a complex number system. You have the imaginary system inside the But I felt like I was chasing a dog around the tree trying to explain to his dad on the phone. It was funny. Okay. It says here, apply the fundamental theorem of algebra to determine how many possible roots the function will have. So I want to look right at this first one. Does my letter have an exponent? Now, before you say yes or no, think about it. Is there an exponent on that x? Is there a 1 right there?
Mm-hmm.
Yeah? So how many solutions would this problem have?
1.
Yeah.
7.5.
Oh, you got it. What about this one? What's my highest exponent? What's my highest exponent here? 2. Okay. So how many solutions would this problem have? 2. So that means it could cross the x-axis twice. This one would cross it once. This could cross it twice. And I use the term could because there are some things that can happen with a parabola, but we'll start exploring that later. What about this third one down here? What about here? Highest exponent is 3. So how many solutions does this look to have? 3. So that means it could cross the x-axis 3 times. I guess I should put S at the end of that. 2 solutions, 3 solutions. Ooh.
They cancel each other.
What cancels each other?
4x.
Yeah. These cancel each other out. So if those cancel each other out and they're gone, and I write it as just
1 solution.
Yeah, it only has 1 solution. So I could rewrite this to be this, which means I have an exponent of 1, so I have 1 solution on this one.
Wait, do they cancel each other out because it's both?
One's positive, one's negative.
Oh.
Amount of sand you took out of the hole, amount of sand you put back in the hole.
It gives you more early arthritis. Don't pop your knuckles because it gives you early.
I'm a little confused on this last one. It's not an x value.
So would it be 0?
It would be 0. Why would it be 0? I like that.
Because
It has this. So I will tell you for sure. This has 0 solutions. But let me show you why it has 0 solutions. Now, I'm not worried that you can graph everything, but if you remember back when we were graphing lines, this would have been a horizontal line like this. So if it's a horizontal line, would it cross the x-axis?
No.
No. If it's not going to cross the x-axis, we're not going to have a solution. So 0 solutions on that one. Good deal. Good deal. We doing okay?
Yeah.
Am I okay on time? Dude, 14 minutes to our favorite time. Yeah, buddy. All right. Oh, dude, look at these graphs. Man, you kidding me? Are we going to have to graph that? And this is where you show where the kid, hey, when do we have to use this in life? I don't know, for the next couple of years until you're out of high school.
In math classes? Yeah, but, okay. My buddy Ruben said you don't have to.
Ruben.
He's right.
Ruben.
I'm just making up names. You know, there's always that. I have a friend that.
Yeah.
Somebody always has a friend that, or has an uncle that, or has an aunt that. They won the lottery and they just sit around and watch just reruns of I Love Lucy and Price is Right at 10 o'clock each morning. Good.
Who watches Kyle XY?
Who watches what?
Kyle XY. Do you know that show?
No.
Oh,
Has anyone
so
seen
nice.
Weeds?
What?
We have
It's
a
called
very
Weeds.
super
It's so
complicated
good.
roller
It's about
coaster,
this
and then
suburban
we have
mom
a
drug
W.
dealer.
Oh.
It's so fun.
Is it on Netflix?
Yeah.
Alright,
It's a good show.
bet.
All right. So apply the fundamental theorem of algebra to determine how many roots, zeros. So let's do this. Let's count as we go across. So it looks like it crosses the x-axis there, 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 and there. How many times does it cross the x-axis?
Like 5 times.
Like 5 times. So the fundamental theorem of algebra would say this has 5 roots. 5 roots means it's 5 zeros. Okay, or 5 crossings of the x-axis. Now, don't worry, we're not going to be starting graphing things that are raised to that exponent yet.
Thank the Lord.
Yeah, we'll get there. But by the time we get there, you'll be well prepared to do it. What about this last one? Looks kind of like a W, maybe.
Out the board.
How many times does it cross the x-axis there?
1, 2, 3, 4.
1 and 2 and 3 and 4. So this was 4 roots, which are 4 zeros or solutions to the problem. What do you think about that? Not horrible, is it? Is there any more notes?
Yeah.
How many more pages? Just 1 page? Like a front and a back?
You're just got one more problem.
Only 1 slide? Dude. Okay.
Okay.
That's it right there. Okay.
Yeah, you have 1 more left.
There's 1 more after this one?
No.
Oh, okay.
This is the last one.
All right. So hang on. Hang on. Hang on a second. It says factor completely. So let's take a look right here. I'm going to highlight right here. So I'm going to factor this out. So now, I know I have this f of x. This just means it's functional notation. That means the same thing as y. But we want to factor out that yellow part. So we just got done with a factoring unit, right? Let's see if I can figure this out. So I know that if I multiply that times that, it looks like I get negative 12. If I get a negative, that means I have a positive and a negative component. And what components would make up 12 would allow me to add them together, one being positive, one being negative. That would give me 4, positive 4. Like, do 1 and 12 add up to give me 4? Do 3 and 4 add up to give me 4? Gosh, there's 1 more factor in there I'm forgetting.
Oh, you could do 6 and
6 and 2. Positive 6 and negative 2. Does positive 6, negative 2 add up to that? Okay, so that means if I did my math here, I'd get this. Right? This is what we've been doing, right? And then if I break that down, say I got an x in common on those first 2. And I got that negative 2. That's x plus 6 there. What do you think about that? So what does that factor to? X plus 6 and?
X minus 2.
There you go. X plus 6 and x minus 2. Now, this is what we had just gotten done with. Now, I'm going to do this. So, what answer is this one? Negative 6. Good.
How did you get that?
Because if I go negative 6 plus 6, I get 0. Right? So what I really did is just did this. I went x plus 6 equals 0. Subtract 6 from both sides. So if I take negative 6 and I plug it back in here, the whole answer becomes 0. the whole answer becomes 0. That means it crosses the x-axis. There's one more 0 or one more solution up there. What is it? Positive 2. Awesome. So x is also equal to 2. And how did I get that? Well, I know that x minus 2 is equal to 0. So if I add 2 to both sides. So I have these two solutions. Here's my answers. If I took those answers and I plugged it back into the original problem, if I took -6 and plugged it back into the original, or I plugged 2 back into the original problem, the whole thing becomes 0. That's the definition of a solution. Huh. Do we have time to do number 2?
I think so.
Okay.
No.
Let's take a look. Let's take a look. So I'm just going to look at this portion right here. I'm just looking at this part right here. Is that okay? So if I look at that part right there, okay. Does it look like I have a greatest common factor? Like, can I factor a number and a letter out of everything, or just a letter, or just a number? What do you think?
Both.
Both. What do you think I can factor out number-wise?
I can factor out 4 and x.
4 and x. So if I factor a 4 and x out of this, if I factor a 4 and an x out of that, that gives me x squared. Is that okay? If I factor that, that's going to give me plus 2x. If I factor that, I get a minus 3. Let's take a look. Does that seem appropriate?
Yes, sir.
Now, we just learned a couple slides back that the highest exponent talks to us about how many solutions we have. Agreed? So how many solutions should this one have? 3, because our highest exponent is 3. Okay. So I'm going to bring this down, right? We talked about that. And then I have this. So let's go ahead and try and factor this. That's going to be -3, which means I have positive and negative. So is there factors of -3 that I can add together to give me positive 2? Are there factors of -3 that I can add together? 1 and 3, which one's negative? So get that. So I have these are my 2. So I'm going to do x squared plus 3x minus 1x minus 3. Look here, that's going to give me x and x plus 3. Remember, that sign comes down, so I factor a -1 out, x plus 3. Down here, I'm going to get x plus 3 and x minus 1. Okay, and that's what we've been doing. So then I'm almost done with this problem. So now we're just going to say, all right, well, I know that 4x and x plus 3 and x minus 1 equals 0. How many solutions did we say this one has? 3, because it has an exponent of 3. So I'm going to take each part. So this equals 0. First part. Second part, x plus 3 equals 0. Third part, x minus 1 equals 0. And let's go ahead and solve each of those. What would this answer be right here?
-3.
What times 4 gives me 0?
0.
0. There's one answer. So if I took that 0 and I plugged it back into my original up here, if I plug 0 in, the whole thing becomes 0. Cool. What is this answer? -3. So again, if I took -3 and plugged it in up here, this whole answer would become 0. Okay. All right, and the last one, what's this last answer? X equals 1. And again, if I took 1 and I plugged it back in to the original problem, the whole answer would be 1. So it was raised to the third power. That tells us we have 3 possible solutions. I see that my solutions are 0, -3, and 1. Those are my roots. That's where it crosses the x-axis. That's it. That's all we're doing. So we're just adding one little extra portion. Okay. Now I forgot what page we're on. Will you remember? I'll figure it out. What did I do? Equals 0. Solving by factoring. Ooh, there we go. Factor any others? Zero product property. Find each. Factor review. Cool. All right, so it looks like we got time. We got some good time. Let's do pages 43 and 44 for our homework. Cool? That's all I got. Sound good? So you guys have the rest of the period to start working on it. If you don't have it with you, maybe